Eclipse. It's Solana on Ethereum. So it's an SVM L2 that uses Celestia DA and is trying to be the highest performance rollup. But actually before that, they were the exact opposite, being a RaaS, helping you deploy multiple rollups. So I'm gonna talk with Terry, strategy at Eclipse, on why they pivoted to a giant, beefy, high performance rollup. Eclipse is Solana on Ethereum, but is that it? Why should people care about Eclipse?
Yeah, for sure. Eclipse is Solana on Ethereum. Technically speaking, we are the first SVM L2. It's the first time you've seen the SVM outside of Solana. It's the first time you've seen an effort at bringing an in-production high-performance virtual machine that also has support for empirically supported local fee markets onto Ethereum. But it is also the start of an experiment where we believe that a lot of people have been building L2s that are kind of similar to what you see on mainnet, specifically Ethereum mainnet. They haven't necessarily tinkered around with the fact that a validity guarantee and a safety guarantee within an L2 is 1 of n, or a 0 of n if you have ZKP that is sufficiently fast at creating proofs. Therefore, can you push the performance of the sequencer to levels that you have not been able to see on an L1? Because then the validator needs to be somewhat profitable. Is there things that you can do because of the unique economics of running an L1 sequencer, L2 sequencer? And that's kind of where Eclipse wants to be.
I guess first let's get into quick intros. So who are you? What do you do at Eclipse?
My name is Terry. I'm head of strategy at Eclipse. That kind of means, well, my job is kind of to do everything and anything that the team requires. And historically, that's been more so of looking at what are the new technical advancements that are happening in the crypto landscape and then feeding that back into the product.
Mm-hmm. And so let me just like hit it off with like the spiciest question, which is like, you guys used to do RaaS. RaaS is like multiple rollups, but like Eclipse is like, you know what, we pivoted and now we're like one big fat SVM rollup. So like, can you talk about why, or do you guys not believe in sort of multiple rollups? Sort of, you guys believe in like a fat rollup thesis? Like just like explain more, I guess, the trade-offs, why the pivots, all that stuff.
Yeah, I think this is very interesting if you think about it in the context of Solana. Like even Solana itself and people in Solana Foundation, as well as the engineers, do not believe that Solana is sufficient for global transaction demand. They think that what you must do is you have to make sure that you exhaust all hardware and software advancements in speed before you introduce fragmentation. And this is one of the reasons why they don't, say, for example, have a dynamic base fee, right? Because they're saying we are going to make validators internalize the cost of all the spam filtering and all these extra transactions that come in that then require them to provision additional hardware to make sure that they can actually look at filter through all these transactions. But we're not going to make the user take on that externality. The philosophy of different L2s have not been of this type, right? Arbitrary optimism have not been of this type where they haven't said we're going to maximize the throughput that is possible on L2, which is fundamentally higher than an L1. And then once that is maximized, we are going to then branch out into OP Stack or Arbitrum Orbit or Nova Stylus. What they've said is we are satisfied with this essentially like mainnet equivalent, but cheaper L2. And we're also going to provide people the opportunity to spin their own infrastructure. What we're doing is kind of a path dependently different take. I'm not here to say that a single L2 or a single state machine is going to be able to satisfy like global transaction demand forever. Now that is stupid, right? Like if you like Bo from Polymer has this great thread where he was like, at Uber, just to power say like a couple blocks of New York City, you needed 10,000 mega ETH. And so if you actually think that the global economy and the world is going to come on chain, to think that one rollup will always be able to satisfy this is crazy. But to think that there is a path dependency on our way to get there, that is not. And I believe that is the ethos that we've learned from Solana, which is insofar as we can internalize the negative externalities of low transaction fees and high throughput, as in like us, the sequencer, and for them, like their validators, and insofar as the foundation can subsidize it in the case of Solana, let's do it so that users are not hurt.
Mm-hmm. That was really good. Typically, my argument against like fat rollups is like, if you like one Solana, imagine two Solanas. Like that's way faster. That's like a very reasonable take. And I guess let's now talk about sort of fragmentation and sort of why the SVM specifically. Why not like I know like Movement is using Move. Why SVM for a high performance rollup? I know there's other like high performance rollups like Mega ETH. So why the SVM? Also, if Solana ever has rollups, are you guys gonna like have a multi-chain Eclipse ecosystem like Optimism and Arbitrum have?
Yeah, I'll start with the second one. If Solana ever has rollups, will we consider multi-settlement? That is an interesting question. And I think being able to onboard liquidity from two of the biggest ecosystems in crypto is attractive. Starknet chose Ethereum and Bitcoin. So I guess they are actually choosing two of the biggest ecosystems. But in my perspective, two of the biggest ecosystems where people actually meaningfully have DeFi activity, have liquidity, and have some precedent of being willing to go onto another execution environment and use their assets there, I think are Ethereum and Solana. So multi-settlement is a consideration. Building out an ecosystem like Arbitrum Optimism, not entirely sure what you're referring to, but if you are asking if we're ever going to go to the RaaS path, it is something that's still open. You know, if there is a world where we have completely exhausted all other options of scaling with hardware, with software, and with everything that we can do, specifically like application-specific sequencing, where it's offloading execution, so offloading ordering, but not execution to external entities. And so we will consider that path when we have the sufficient transaction demand to require it. Now, let me go back to the first question. Why the SVM? If you want to have in this path dependent rat, which we talked about after the first question, if you want to have a single state machine, there's a couple things that you require. Number one, you need extremely high throughput. And if you look at all the current existing execution environments, I'm not going to say virtual machine, I'm going to say execution environments out there, what has the highest in production TPS? And it's very obviously Solana by like an order of magnitude, and that's thanks to native parallelism, which is fundamentally faster than block STM. And that if you use the SVM, you tell the virtual machine or you tell the execution environment all these these are the accounts that I'm going to access before. And so whereas in block STM style parallelism, you have to assume that nothing is contentious and then re-execute if there are transactions that access the same locks or the same state. In Solana, you already know at the scheduling layer beforehand what transactions are conflicting. And we've done some tests of the Move VM, specifically the Aptos Move VM versus the SVM. And we've concluded that the SVM is an order of magnitude faster. Now, that has nothing to do with, that may have something to do with block STM versus pessimistic parallelism, but we've talked to Avery about it, and he's more so of the idea that Move VM has a lot of overhead. I mean, that's additional proof that we should have used the Solana VM for performance. That's the first thing that you need. You need high performance. Second thing you need is empirically observed divergence between the average fee and the median fee. Now, the average fee is the average of all fees paid by people transacting on the network. This is heavily skewed to be higher because people are willing to pay to the marginal profit that you make from inclusion. Right. So say I'm a searcher and there is some highly attractive arbitrage opportunity that's going to make me 15 ETH. Oh, okay. Front running opportunity that's going to make me 10 ETH. There's some arbitrage opportunity that's going to make me like 2 ETH if I go and capture it. Now, in order for me to capture it, I need to bribe a validator to include me at top of block. So the fees that I'm going to pay, say that MythBoost doesn't exist, but the fees I'm going to pay in the case of priority ordering is going to be very, very high. And empirically speaking, I believe 40 or 50% of the total priority fees paid and sequencer revenue made by base and OP stack chains come from the top first transaction in the block. Now, that's going to skew your average fees way up. The median fee is, if you and I go on the chain and I just want to send you USDC, like what do I pay? In EVM chains, the correlation between the median fee and the base fee, the median fee and the average fee is very high. In fact, in Ethereum, it's nearly 1. But on Arbitrum, it's less. On Base, it's a little less. But regardless, what you don't want as an application that coexists with other applications is, your store is getting a lot of customers. Now, suddenly, it is more expensive for people to buy my goods. And if you think about this in the real world, it kind of doesn't make any sense. It's kind of like saying, if my barber shop has a lot of customers, suddenly the pharmaceutical company, like their product costs go up. Right? It just makes no sense that another dApps activity is going to affect my activity. Now, that is a problem with the EVM. That is not a problem with the SVM.
Another question. I guess let's now go into architecture. So, how exactly can is this like an optimism? Like you guys just put the SVM on optimism? Like, just talk about the architecture in general. I can't really imagine sort of what you guys did.
Yeah, we had to roll our own stack, so we couldn't use the OP stack. But essentially, like you can think about it as the OP stack, right? The OP stack is a couple elements. It's um, Ethereum settlement. There is an OP full node that reads the L1 and derives the chain, thereby being able to reconcile deposits which occur on the L1, as well as data availability, um, kind of like data availability data that's deposited onto the L1 via the L2 sequencer, and then there's the sequencer. We are the same. We have a sequencer. In fact, we have four sequencers that are producing blocks and therefore producing data. They write the transaction data to Celestia. And then currently this is not implemented or this is not public, but we will also have the ability for users to run a full node to derive the current state of the chain by reading both Ethereum and Celestia data, thereby allowing trustless deposits from Ethereum to Eclipse.
And so, is Eclipse a ZK or optimistic rollup?
It's optimistic.
Okay. And I guess now let's talk about uh actually let's like go back. So there's four sequencers. So you guys have a I don't want to say like decentralized, but like like a decentralized sequencer for Eclipse. Is that right?
Yes, we have
Oh
a
wow.
decentralized
Okay.
sequence.
I thought you guys were gonna go the like beefiest like single sequencer sort of like mega ETH route. Can you talk on why you guys didn't do like one absolutely massive and instead go like four relatively big sequencers?
Yeah, and we're going to go for absolutely massive sequencers. Yes, that's going to increase our fixed cost by 4x, but I think it will be sufficiently offset by transaction costs. So, I mean, the idea is if you look at the requirements for short-term censorship resistance, right? Like the recent Init4 articles by James Presswich, he essentially argues, and incorrectly doing so, that um, if you have any assets that are on the L2, even if they're bridged from the L1, if they are locked in any contracts such that contentiousness can prevent a forced exit transaction from occurring or from not reverting, it is impossible to enforce a real forced exit. Right. So his argument is saying, okay, you have funds in or like funds in Aave, right? And what the sequencer can do is before your transaction, which they include at the end of the block, always include a max borrow from the same Aave pool, such that you can never withdraw your liquidity from the Aave pool, even with the forced inclusion mechanism. Now, in order to make sure that this doesn't happen, the way that an L1 works is they have means to ensure short-term censorship resistance, such that given enough rotations of the validator set, you're going to come across someone who is building honestly and not going to try to censor you. And this is the idea behind why Ethereum thinks solo stakers are so important, because solo stakers are, specifically solo stakers that self-build, are so important because they are not going to engage in institutional and political games. My opinion is that if you have a sufficient number of highly regarded MDs that whose actions are very public, as is inclusion in a blockchain, and you have the option to be able to remove someone if they are misbehaving and verifiably misbehaving, although intersubjectively attributable, that they will have sufficient incentive to basically not act maliciously. And it actually gives quite good decentralization guarantees versus if you have an open and permissionless market, say, for example, the Ethereum block building market, then you can have forces of economics and forces of the nature of the market microstructure itself lead to centralization. So right now, I believe two builders are responsible for something like 90 to 95% of all blocks. But in Eclipse, you have four builders responsible for 25% of all blocks. And empirically speaking, that actually provides quite good censorship resistance and decentralization guarantees.
Mm-hmm. Another question is, so there's four. Tendermint requires four nodes in order to work. Are you guys just using Tendermint?
No, we're actually just using the Solana consensus method, which is PBFT, which is related.
Yeah. Oh wow, I didn't know that. So now let's get into application specific sequencing. So just like, what is that? Why would you want that? And how is that different from sort of application specific sequencing, but on your own completely entire roll up? Like, how is that within a shared execution environment?
It's very funny. People like kind of associate us with application specific sequencing. I mean, I think you shouldn't associate Eclipse with application specific sequencing. You should associate me with application specific sequencing because I'm quite a fan of it. I think if you want to do a single state machine in this path dependent way, there are three things that you need. Two things we talked about. One is local fee markets, which is the divergence between the average fee and the median fee. Number two is high throughput, such that you can actually support the transaction demand of multiple applications on your chain. But number three is incentive compatibility. It is kind of funny to think about that, like, as an application, you build something that's interesting. You build infrastructure that's interesting such that it allows people to trade assets between each other. It allows people to, deposit asset here and take out a collateralized loan. But for some reason, a lot of the value that's generated because and thanks to this application that you've created leaks to people who are completely unrelated to you in the value supply chain. Specifically, it leaks to searchers and validators. And I can't really, like, every time I kind of think about this, it's like they are completely unrelated entities. Like, yes, I deployed to a blockchain, but for some reason, someone who is validating the blockchain, because they get to, change the order of these transactions, gets to say or gets to keep the vast majority of the value that's generated from my DApp being there. And I think that is the main reason why there's so many people who are leaving and rolling their own app chains. I think that's why Uni is rolling their own app chain, because they want to control the MEV flow. They want to have some type of new sequencing rule, but also they are leaking a huge amount of MEV to Ethereum validators that they can capture themselves. All right. So if you want to have a single state machine, you need to be incentive compatible. What that means is you need to give dApps the value that they create via having interesting state. Now, there's two ways to do this. Number one is some sequencer level value attribution and value redistribution mechanism. Now, Unichain has MEV taxes, which is essentially saying that everyone can set their own price in order to access their contentious state. So you're saying, oh, my application is super interesting. I'm going to charge people $10 in order to access it. I'm saying, my application, maybe it's less interesting. I'm going to charge people $5, but you and I get to decide. Number two is you just let people pay, whatever they were originally going to pay for contention, and then you kind of redistribute that pro rata to some existing quantifiable measure. So Blast does this by base fee. It's not a perfect mechanism, but the idea is, if there is a transaction that atomically routes through you and me, say I use 10 gas, you use 20 gas, you're going to get twice as more of that priority fee, sans the base fee of that user's transaction. Now, what that incentivizes people to do is, like the first response a lot of people have when they hear this is like, oh, then protocols are incentivized to make horribly gas inefficient contracts. Well, then if you do that and people still use you and users still use you and people still integrate with you, it means you have pricing power, right? So what that means is actually it kind of devolves into MEV taxes at the end of the day in an efficient market. So what a protocol is incentivized to do is make if they have like intense pricing power, make their contracts horribly, horribly inefficient, such that despite the user still paying that much, they will get the vast majority of all kind of user transactions as well as composable routes. But the other way to do this is S, right? So the third incentive compatibility method is to redistribute and give dApps the value that they create. There's two ways to do this at the chain level, which is MEV taxes and pro rata distribution. And then the third way, the second way, which is not at the chain level, which is at the application level, is application specific sequencing. Now, the way this works is you submit transactions to the application then orders it themselves through various mechanisms, various levels of decentralization, and then submits it as a bundle to the sequencer or block builder for inclusion. So essentially, they get to control the ordering of the transactions, which is where you get MEV, which is where you get value flows. Although they do have to pay a little bit of taxes still to the validator, the bundle or the builder or whatever. The app gets to control the way it's sequenced, and therefore gets to control the way the value is internalized to the app, and then therefore redistributed back to their users. So this is why I'm very interested in AS. I think dApps should own the value they create. Maybe that's a contentious opinion. I don't think many people care about it today, but I think that is the future.
Mm-hmm. So, application-specific sequencing is like great and all, but like, and the SVM has the sort of positive effect of, the more things related, the more activity. It doesn't like congest other applications and like make the UX of one application sort of horrible because one is doing well. Sort of has like a positive, I guess, like ecosystem effect. But like, why deploy on Eclipse? Like, there is Solana, there is Ethereum. Do you think that this sort of middle ground of being like high performance, but like, oh, we're also like a roll up Ethereum stuff? Do you think that that's gonna, who is that gonna attract, and why would someone like deploy on Eclipse versus sort of get the security from Ethereum and like a like an ETH aligned roll up, or like more of a like degenerate fun Solana application on Solana?
Yeah, I think first, I think alignment games are dead. But like, are we an ETH align rollup? Yeah, we're an ETH align rollup. We use ETH as gas. We settle to Ethereum. We bring on Ethereum we as assets, and ETH as gas. ETH is the canonical asset that is on our chain. Uh, do we inherit Ethereum security? Some of it, eventual Ethereum security for L1 bridged assets to the L2, same as any other chain. Um, why would they deploy on us above Solana? Now, that is a more interesting question. At our current state of development, we are mainnet equivalent. We have 350 millisecond block times on average, which is similar to Solana, not very, very much faster, but that's something we want to bring down. So we want to bring down latency. We want to increase block size. We want to increase TPS. And again, that's something we can do uniquely as an L2. For example, if FireDancer goes live tomorrow on Solana, it takes a while for them to become the majority client, and therefore people to be able to take full advantage of the speeds of FireDancer. We can make FireDancer a majority client the day after FireDancer ships on mainnet, such that the entire cluster becomes equivalent to the maximum TPS possible by FireDancer. And also, part of it is we are working on this. I remember I told you, in order to have a single state machine, this path dependent matter, you need three things. The third thing was some method that allows apps to own their own value that they create. We want to heavily support AS on Eclipse. And we also want to have a chain level value redistribution strategy, which we're still working on. But we want it to be such that it is incentive compatible to deploy on Eclipse, where apps make the vast majority of money, not the validators, not the sequencers.
Mm-hmm. But currently, and I also want your opinion on sort of like liquidity and sort of because the argument for Ethereum was like Ethereum has liquidity, it has mindshare, it has attention, and that was like the narrative for a very very long time. And then all of a sudden, like there's also the like Solana has low TVL, no sort of DeFi activities, and then like it switched, and now people are like deploying on Solana, even though I guess their liquidity isn't like as amazing as Ethereum's, but like it's also like just fast paced in Solana land. So like, what do you think about liquidity, and how do you compete with Solana's liquidity? Do you think liquidity is important? Do you think Solana liquidity is going to come over to Eclipse? Just like your whole opinion on the liquidity space.
Oh, this is a great question. So I guess first and foremost, we have around, I believe, 150 million, 200 million in liquidity. A lot of it was interest in our NFT collection. And I think generally liquidity is not going to be an issue because we'll have canonical bridging from Ethereum. Excuse me. I think what's the biggest issue for any execution environment is mainly activity and distribution, like top of the funnel activity and distribution. And that is a challenge that we have to solve, right? Like, why would someone do it? Because of the technical characteristics of our chain. Perhaps they like our community because our go-to-market is good, because we've been able to, garner attention and mind share above other execution environments and ecosystem projects, because we have a strong ecosystem team that is able to onboard some interesting DApp and some interesting asset creation methodology that doesn't exist elsewhere. Like, these are all candidates for why, but ultimately it's for us to do so in the next 6 months to prove that actually, yes, there's something unique that you can do on Eclipse that you can't do elsewhere, and therefore garner users that might have been on Ethereum mainnet or Solana or Arbitrum or Optimism.
Mm-hmm. And so, honestly, I'm pretty satisfied with all of your questions. I don't really have any more critiques. Is there anything that I'm missing? Anything that sort of isn't well known about Eclipse? Misconceptions?
I'm not sure if there are misconceptions. I guess like it's surprising to me that people have. I think a lot of people have come to know us more and better over the past, say, 4 or 5 months, as we've definitely gone out and posted a lot more on Twitter and engaged with the community. There are a lot of interesting applications that are on Eclipse that you can play around with today. You can bet, you can lay parlays, you can access Polymarket. There's not a Polymarket deployment, but you can access Polymarket through Eclipse. You can trade meme coins. There's NFTs. We are kind of at the forefront, I think, of this like NFT revitalization. A lot of people are excited about the upcoming secondary marketplace called Scope launch on Eclipse. So a lot of activities happening. A lot of things are happening. So that's what I'm excited about. And yeah, that's what I'm excited about.
Honestly, I'm pretty satisfied. I think this is a wrap up. So, anyways, thank you so much for coming on. And yeah, I don't know what the podcasters are supposed to say at the end to wrap things up, but yeah.
Same. I was at the same problem when I had guests myself. But I think a lot of the people that I've seen that have done it well, they just go, "Thanks, done,"
Mm-hmm.
and then boom, it's over.
Right. Another question: why the name Tete Ho? Yeah.
I don't want to dox myself, but that's my real name.
That's your real. Oh, okay. I thought it was like okay, and then
Not Tete Ho
oh,
Ho.
okay.
Like Tay Ho is my real name.
Oh, okay. And then
Yeah.
another thing is that how did you get into Eclipse specifically?
Yeah, for sure. I used to be a venture investor at 1KX. I was doing infra scalability, ZK. I did a big focus on ZK for a while, and then generally more so scalability DA. Um, we saw DA bottleneck being lifted. I think it was like 2023. I was studying EigenDA's white paper as well as Celestia's construction. This was as Celestia was going to mainnet. And it was very obvious like the DA bottleneck was no longer a problem. Then what's next, right? Like once you have no DA bottleneck, what do you play around with afterwards? Then it's obvious. It's execution, right? So then who's playing around with execution? And I looked at the market and there were realistically like 2 teams, 3 teams that were doing it in an interesting way, right? I don't feel like making a whole new L1 is that interesting anymore. And so the 2 teams being Eclipse and Mega ETH. And so I joined Eclipse. I was just like, hey, you guys looking for people? And they were like, sure. And then, a week later I was hired, and that was about 7 months ago.
Oh wow. Yeah, no, I didn't think about that. Another thing is that if there is a better VM, would you guys switch? If there's better DA, would you guys switch? If like Ethereum is like now scalable, would you guys be like, okay, no more Celestia now, Ethereum? If you're, like let's say like Eigenlayer, you guys like would you guys switch or choose if there was a better execution or DA layer?
uh, Execution. So there's quite a lot of components in order to become a better execution layer. Like not only do you have to have intrinsically good components about yourself, for example, this divergence between the average and the median fee, or the fact that you have pessimistic concurrency and therefore better performance over block STM. Like these are intrinsically good qualities, but fundamentally you need the third and final quality, which is that you need an ecosystem that already exists, and or you need to build it yourself, right? Like the perks of the fact that like the perks for every EVM L2, and I feel this very like strongly building an SVM L2 for the first time, is that there's all these freaking tools for you that come out of the box and work already without you having to go out and do some special integration work or like, give a grant or pay some infrastructure company to tailor make it for your needs. And this is huge, man. This is so huge, right? All these EVM L2s that are launching, you can launch for virtually nothing, like on Conduit, a Caldera, or on Initia as a Move VM. Like you can launch rollups for very, very cheap, and they give you all these things out of the box. Now for SVM rollup, like we didn't have any of that, right? Like wallets, there's no, for example, there's no such thing as a chain ID in Solana. Then like as a wallet, right? Like how do you expose that to your users? And no one knew. When we were the first people who had to explore this problem. And if you use dApps on Eclipse, you'll realize it's not like there's no like network thing where you like switch it and then there's a pop-up and you click OK and it changes your RPC, which is the MetaMask flow. You just click a button and then it automatically switches your network, right? And it's like a completely foreign experience that dApps had to learn, wallets had to learn, RPCs had to learn, bridges had to learn. And we were coming at a time when infrastructure companies were just finishing their Solana integration, right? Like Dune just finished their Solana integration. Now it's going to be way harder for us, therefore, to get these integrations than it would be for a new EVM L2. It's quite a struggle. I even forgot what the question was because I was kind of going too deep into this.
Oh yeah, that was really good. It was about if there was a better VM, would you guys switch? If there's better DA, would you guys switch that as well?
So makes sense. So VM is going to be very hard. See how long it took Solana to even like come neck and neck with the VM in terms of general mind share and conversation. I would say it's not even there yet. DA layer. I don't know what a better DA layer would be, right? So Celestia gives us pretty much everything we want, which is, I want it to be consumer hardware verifiable. Like DAS does not exist on any other DA layer, or I mean, DAS does not exist in DA layers of different types of construction. For example, VID DA layers. And we want it to be very high throughput. Celestia has a roadmap to 10 megabyte blocks with very fast block times. And kind of those two, we want it to be like relatively cheap, right? So we have all those things out of Celestia. I don't think there's any reason to switch in the foreseeable future. And like Ethereum is never going to be, I mean, I don't want to say never, but if you look at like Danksharding target rates, Ethereum is not going to be sufficient.
Yeah. Another thing that you brought up with the sort of like ecosystems and like the SVM is there's this problem where rollups will be like EVM identical or very close to it, whatever. And then they're sort of like just like Uniswap copies and like Aave copies, and then like that's like the ecosystem. What's up with that in SVM land? Do you guys fear it's just going to be like SVM apps just like redeployed on Eclipse and like that's the ecosystem, sort of like a copy paste ecosystem? Like what's your opinions on that? Yeah.
Yeah, we precisely don't want that, right? I think the way to get around that is go out there and try to onboard very unique dApps, incubate some yourself, but also support a lot of the people that want to come over from Solana. I think a perk from Eclipse is, empirically speaking, like around 60 to 65, 70% of our users don't have a Solana wallet. Like it was their first time. They're not bridging into an existing Solana wallet. They created a fresh one for Eclipse, which means that could probably mean that they're not Solana users, right? Like we have a lot of people who are pure Ethereum users and only Ethereum users who have never used Solana before, now using SVM L2. So from the perspective of a Solana dApp, if you look at it from a myopic perspective and you look at it from a perspective of a Solana dApp, it's like, oh, we're going to deploy here because there's all these additional users that we can access that we can't access if we're here. Now, from the perspective of an Ethereum user, it's like, oh, there's all these new experiences that you can access here that I previously could not access on Ethereum. But if you look at it, of course, from a combined crypto user landscape, which I think, I would imagine most power users are pretty chain agnostic, then yeah, it's on us to deliver an experience that is not possible elsewhere.
Yeah, that was pretty good. I'm pretty satisfied now. Is there anything else you want to talk about, or should we wrap it up for real this time?
Yeah, let's wrap it up for real.
Oh yeah, it's wrapped up. Thank you.
Cheers.